Hi students, welcome back. Today we are going to learn about rate of reaction. Still remember what do you understand about rate of reaction or not? Do you still remember? Reaction, it means a reaction, a process happening between two things, two material. For example, a reaction. If I take a fire and burn this thing, the plastic spoil already, then this is a reaction. Fire with this black color thing, I think this thing will become black because from a plastic and oxygen, it will become like carbon, more towards carbon because it will become black color. So this is a reaction from something become a carbon. And we want to know in this chapter the rate of it, the rate. So either I want to make this faster, I just put more fire and burn it. So this I would say this one is a high rate. The reaction is very fast. Or I put the fire a little bit, so the reaction is very slow. So in this chapter, we are going to learn the factor that are affecting the rate of the reaction. As far as we can see, even for here, we can see there's a temperature. Correct or not? Because if I, of course, like so logical. If I put more fire, of course, burn faster, lor. If I put little bit of fire, of course, it's still slow. But the end result is still the same. It's still a black color something, carbon. So we want to know what are the factors to make the reaction fast or slow. The first one, we can see, this one you need to remember, it's so common. I don't, so common until I don't know whether they want to ask an exam or not. Temperature, high temperature, the faster rate of reaction. Concentration, in terms of acid, for example, more acidic, more reaction, less acidic, less reaction, concentration. Catalyst is if you got that thing, then the thing will process faster. Example, the catalyst. Can see catalyst or not? You can see a catalyst here. Can see or not? The saliva. The saliva is a catalyst. It's a biological catalyst that can make the digestion system faster. Some people don't know why your tongue got water one, the saliva. Why? No water also can eat, but your saliva not only to dissolve the substance, but your saliva also function as a biological catalyst, which we call it as enzyme, to make the food digest faster. Here got enzyme, here got enzyme, stomach got enzyme, here got enzyme, there got enzyme. A lot lah, different enzyme for different food. And then we have pressure. Again, high pressure means cook faster, correct or not? That's why we got the pressure cooker that you can close, put the fire, more pressure. It depends on what food lah. Then you cook faster, correct or not? Like you are cooking, right? So you cook 2 Maggi mee. 1 Maggi mee, you open the cover. 不要 no one to close. 1 Maggi mee you close. Which one is cook faster? The Maggi mee that you got close, got 关那个盖. Why you want to 关那个盖? Because first thing is to increase the temperature. Secondly, also it will increase the pressure. So your Maggi mee can cook faster. I don't know whether you got cook Maggi mee, you got close the cover or not. Yeah, it depends on you. Okay, personally, I feel right. You need to cook faster. That is taste nicer. Size of the solid. This one is a bit to balik. If the size of the solid is bigger, the reaction is slower. If the size of the solid is smaller, the reaction is faster. For example, let me think of example. I like sugar lah. Okay, sugar got 2 types or not? I don't know whether you got help your mom to cook or not. One is the sand sugar, like very fine sugar, like you can buy gula halus. Another one is a brown sugar, big one. When you buy, or you can see the gula batu, like a stone one. So this one and the sand one, I take 500 gram. This one, the gula batu, I take 500 gram. So both have the same amount of sugar because I'm taking 500 gram, 400 gram, and I put in water, and I wait, or maybe I stir it. I see who can is faster. Of course, this one is faster, but this one is the size of the solid is smaller. So the hypothesis is the smaller size of the solid reactant, the reaction will be faster. Or the bigger the size of the solid reactant, the reaction is faster. So this one is a bit special because all this temperature high, then high temperature, high reaction, got catalyst, high reaction, high concentration, high reaction, high pressure, high reaction. But this one is a bit special. Big, solid, low, or small size of reactant, high rate of reaction. This one is a bit special. But you don't memorize like this. It's easier to memorize if you understand the concept. So you put in your mind the sugar, then you no need to memorize. If you memorize, what for you want to memorize something that you can understand and it's easier for you to write in your exam. So we already do this, blah, blah, blah. Again, we can see number 5. When the size of the solid reactant decrease, the rate of reaction increase. Not asking you again to memorize this, but to understand this. No need to copy this sentence, but you can create your own sentence. Since this is not a English class, right? You just can say like talking to your friend. If the size of the solid reactant is smaller, the rate of reaction is increased or more rate of reaction. It's still the same thing. Blah, blah, blah. We already learned this, so I'm going to skip this. And we are going to look at other experiment. So we stop until here. Okay, so basically these 4 experiments is still the same. Again, for the hypothesis, for Form 1 until Form 5, the hypothesis is always accepted, even though I haven't do this experiment. The smaller the size of the reactant, the higher of rate. Correct or not? The smaller. So if you ask me to do experiment, probably I will use sugar because I can get sugar from the Family Mart, Econsafe, Eon Big, or whatever lah. Because I know. So let's see what he want to do. Oh, he want to use marble. What experiment he want to use? Oh, time taken to collect 300 grams of gas and hydrochloric acid. Okay, this marble is not the marble that you throw. Okay, so marble got 2 meaning. One marble is the round marble you can throw, you put in your aquarium to make it nicer. And today you're going to learn one more word. If you do not know this word, another marble is the limestone. For example, we can say in the cave, there's a lot of marble. Instead of saying limestone, you can say marble, or you can say the table is made up from the marble, means the stone table, like a marble, very expensive table because it is made from a marble, something like that. So when you use marble and they want to put hydrochloric acid, because when you mix acid with limestone, it will produce a gas. So from here, I can see that limestone is actually calcium carbonate plus acid. For example, hydrochloric acid, you will get calcium sulfate plus carbon dioxide plus water. So basically, the gas that you collect is carbon dioxide. You can use your anything to do this experiment, or maybe you can use the chicken egg, correct or not? You just take chicken egg, because the chicken egg also got a lot of carbon, and you use maybe vinegar. Well, I think vinegar will make the chicken egg produce bubble acid and the egg, the chicken egg. Up to you. Up to you how you want to do the experiment. You want to use sugar also can. Easier lah, just use sugar also can. Oh yeah, because it's not the reaction. Okay, it's a dissolved experiment. How fast the thing can dissolve rather than how fast the reaction can occur. Because if I use sugar, it is not a chemical reaction. It is a physical reaction. Material, again, I use a marble chip, large one, and the acid. So let me ask you a question. Like, if I haven't seen the data yet. I just want to ask. I use large marble chip, produce more bubble gas, or I use a smaller marble chip, I produce more gas. So I asked my student and he say it's large. Obviously it's not large, okay? Why is it not large? I already say Let's say sugar, fine sugar means a very small sugar, 500 gram. Large sugar, like a stone, 500 gram. Which one is faster? The small size sugar that is faster, the rate of reaction, because it got more surface area. So the answer will be large marble chip is the rate of reaction is lower. Small marble chip is faster because there are more rate of reaction. More surface area. So let's do this experiment. This is talking lah, talking. But even I don't read this, but roughly I know what they are going to do. What they are going to do is they are going to take the marble chip, big marble chip, put in the acid. Is it about concentration or what? Let me see. Size, but they are talking about size. So they are going to they put the marble chip, and small size will produce more bubble gas. Big marble chip with the acid will produce a lesser gas, and the constant variable, for example, will be the acid, the concentrated acid, because I don't want to take strong acid and weak acid. Acid same, weight, mass same, but only one is a big reactant, small reactant. So after I do the experiment, okay, so we got the answer. Let's assume the answer. Large piece, which is actually more, I would say more slower. So time taken, anything like I just write 1 minute, for example. 1 minute. Small piece will be faster, so I will just write 30 seconds. I just create the answer. But one thing I know, this one must be more. Okay, large piece, the time will be more because the reaction is slower. Okay, so data analysis, compare the time, blah blah blah, compare the rate of compare the time taken to 30 cm of carbon dioxide released from the reaction using large marble chip and small. So I already compare. So 1 minute minus 30 seconds will be around 30 seconds. So that's the difference because the question say ask me to compare. So I compare lah. The difference between the large marble chip to produce 30 cm is 30 seconds more than the small pieces of the marble chip. Number 2, compare the rate of reaction using the large pieces of marble chip to the rate of reaction of a reaction using a small reaction of marble chips. So this one I would say, I want to compare lah. So I would say large pieces of marble chip, the reaction will be slower. Careful, I say slower. Small pieces of marble chip, the reaction is faster. Question: how does the size of marble chip affect the rate of reaction between marble and hydrochloric? So this one I want you to try to give me the answer. You can go Google to find the answer, and I will wait for your answer. So my student, So my student answer something like they just mentioned the answer is very long. It's something like the smaller size. I don't know lah, but something. But the key word that I want to listen to my student answer, and my student answer correctly, is the increase of surface area. That's the key word. Because the smaller the size chip, this is my answer lah, because I forget my student answer. But the keyword because teacher mark teacher just see the keyword. So the keyword is the surface area. The smaller the size of the marble chip, it will increase the surface area for the reaction. Since more surface area are exposed to the reactant, so the rate of reaction will be faster. You get what I mean or not? But the keyword is, this is the keyword. The keyword is, if you use more pieces, surface area is increased, faster reaction. So 3 keyword. Small, or if you want to use big marble chip, surface area is little, therefore the rate of reaction is also lesser. Cannot. This is the 3 keyword. How you want to write the sentence is up to you, but the keyword must be there. Yeah, the student asked me, what does this mean? Let me think. Yeah, it's a very difficult thing when a student asks me to explain this, like, because the student mindset, if you say small, then less reaction, big, small reaction. Because student mindset is always like this, But this context that we are not talking about the size, not this big and small. We are talking that both have the same size, but this one I cut until send. This one is still a big thing. So it's not small thing comparing to a big thing. It's big thing compared to a big thing, but this big thing I cut. You get what I mean or not? So let's say I take a marble chip. Let's say this is the marble chip. Big marble chip. Both of these marble chip is the same, which is actually 50 gram. But this one I bring to the kitchen and then I and then this one becomes sand. Sand, and this one still become big. Still big. So I measure again to make sure that this experiment have no fallacy. So this will be 50 gram. Let's say because I know I the sand will go out. So I will add little bit more. So So I will measure it again. So I got the 50 gram of the reactant and also the 50 gram of the marble chip. And now both of these things I put in the acid because it will produce a carbon dioxide gas. Which one is faster? Yes, correct. The student say it's the same one. So this one, the reaction will be faster. This will be slower. But you can see or not, this one is small. Small, what is it called? Small, what is the hypothesis? Small what? Smaller size of reactant. Let's just put here small size of reactant. This one is big size. So you get what I mean or not? Both is the same, but one is the small, one is big. But the smaller one has a faster reaction. The bigger one has a slower rate of reaction. Very good. I hope that I can answer your question. Next, a bit more, then we are going to take a short break. To study the effect of catalyst, very easy to affect the catalyst. So one jar A I put catalyst, one jar B I don't put. Jar A will have a faster rate of reaction, jar B has a lesser. We haven't do this experiment, but we read from book, probably that will be the case. Actually, to learn science is better for you to create your experiment. I don't know maybe it's too difficult but when you go to university and master level, you need to do your own experiment. You need to do your hypothesis. You need to do your own experiment, and that is fun because there's something that you want to learn. I don't know what experiment you want to do. Maybe you want to learn something like girl like to eat ice cream more than guy in your Methodist boys school. I mean a Methodist boy and girl school, I don't know. Let's say it's a boy and girl school. So you want to measure, you do questionnaire, and you want to really prove your hypothesis that girls like ice cream more than guy, something like that. I don't know. It will be helpful if you want to do business, correct or not? If you're a canteen person, you want to do some experiments so that if you want to do ice cream, you want to make sure that you can sell the ice cream. People want to buy the ice cream. Of course, your experiment is very, very small scale. It's a very, very small experiment. Big company, I don't know, big company like Toyota, Honda, their research is very big. Like this steering, you want black color, blue color, how big, how small, accident, here bang, there bang, how to die. Toyota, Honda, Proton company, they got a scientist, they got the experiment, everything, but they design it by themselves. So you also can design your small experiment and it's more fun. So blah 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 here to study the effect of the catalyst and the rate of reaction. I don't want to read all this. Manipulator obviously is the catalyst. For me, if you ask me to do, the easier I will use my saliva because I know my saliva is the catalyst. So I will use my saliva and to mix with food probably. I want to use my saliva to mix with rice. And then this one is just rice mixed with water. This one is saliva plus water plus rice. This one is just rice plus water. So both also liquid. I stir it, right? And I will test it whether it has glucose. So I will add what is the test? Benedict test. Benedict test. So probably this one will become brick red precipitate. This one is no reaction. Probably it's something like that. Like if you ask me to do the reaction, I don't know if it will work or not. But if no work also never mind. You can explain. Oh, this experiment failed. You ask your teacher maybe because of this, because of this. But it's still an experiment. This is the fun of it. What they want to do is hydrochloric acid and sulfur. So they use catalyst. What catalyst they are using? Zinc. Zinc is the catalyst that I want to use. Hydrochloric acid and copper sulfate solution. So they do and to check again the volume of the gas. V2 they want to measure whether more gas and the timing and the gas. How much time, let's say how much time it needed for the gas to reach 30 cm cube. So let's see. Here it is. It can be 30, 20, 10, 100, 150, 200, 1 liter, 1 million liter, also up to you. But it must be reasonable. You put 1 million, how you're going to measure? Or you want to put 5 cm, so small, how you want to see. So that's why science, everything we do in experiment, it must be explained, reasonable. That's why when they go to PhD, when they get their thesis, their research, PhD, become doctor, you need to do research. You're able to explain. People ask you why you want to take 30, why not 60, why not 100, why you don't want to do this, why you want to do that. Then you need to talk and you pass the thing, only you got the PhD and then you got your doctor title. So a mixture of the conical flask, zinc please and hydrochloric acid. Okay. Zinc please, hydrochloric acid and the copper sulfate solution. So this one is this one obviously it will be the catalyst. So basically, I know copper sulfate solution is the catalyst, right? Because this one will increase the rate of the reaction. Correct or not? It is not mentioned in here. Just give me a moment. Yeah, so the copper sulfate is the catalyst. So I just write here. This is the copper sulfate. Copper sulfate. Yes. Catalyst. So the copper sulfate solution is the catalyst, and the other one is so which one is faster, up or down? So my student say down. Yes, it's correct. Down will be faster because down is a catalyst. So now to ask you a question. Can you just predict the timing for up and down for me? Okay, very good. So I just asked my student. He say he want to put here 1 minute. Here he want to put 50 seconds. So because here is S, so I don't want to write 1 minute. I write 60 seconds. Makes sense, right? Because 60 is lower, 50 is faster, something like that. Up to you, okay? You want to do 120 with 60, 300 with 200, up to you. So we do, and we compare it, and the conclusion is accepted. What is the conclusion? The conclusion will be, where's my conclusion? Presence of catalyst increase the rate of reaction. Okay, so the student asked me, what is a catalyst? Catalyst is a substance that increases the rate of reaction without itself undergoing any permanent chemical changes. What is catalyst? For example, my saliva is catalyst. Is to speed up the reaction, but no change, right? Itself no change because my saliva still got here. Of course, I don't swallow my saliva. I can swallow my saliva, but saliva is still saliva. You can use like unlimited because it won't change. without itself undergoing bend, and it speed up the reaction, increase the reaction, so the reaction is faster. It's anything, could be your saliva, could be zinc, could be copper, it can be anything, as long as the something increase the rate of reaction without itself change, that is a catalyst. Okay, so catalyst will increase the rate. It's just anything lah, something to increase the rate of reaction, but itself won't change. Maybe one example I can think of, actually it's not, it's just an analogy. It doesn't mean oil is the catalyst. I just say, for example, it's like oil. When you put oil on your soup or cooking, it will actually cook faster because oil boiling point is more rather than you just put in water. But after the oil finish, you still can take out the oil because it float on top. Something like that lah. You get what I mean or not? Means it's something to make it cooking faster or the process faster, but itself won't change. This, for example, like the copper solution that we do is a catalyst. Means faster lah. Put in means it will go faster. No put means it won't go faster. It still can go, but not fast. Okay, so if you don't understand that, I teach you one trick. If you don't understand, just memorize. Memorize this definition. Just memorize the exam ask, just write. Just memorize it. Then maybe after you read, then you understand. So that's it for this video. I hope to see you next time. See you in the next video. Thank you and bye-bye.